So anyone who doesn't want to be recorded, now is the time to exit left. And we're, I think, I'll admit that we have not been as diligent about posting our recordings as we used to be a long time ago. So we're trying to get back into the habit of, making these meetings available to anyone who wasn't able to join live. We have members really around the world, so there's no time of day that will work for everyone. I think we tend to gravitate towards this early West Coast, late Europe, really bad time for Asia. And we should probably try to find a way to alternate. So that's another idea as we try to grow. But we're also trying to do these regional chapters. And this is ostensibly a meeting of the Bay Area chapter, even though we have people from non-Bay Area locations. So, Ricky, do you want to talk a little bit about this idea of the chapters?
Yes. The idea is to get a route to grow, and of course we are all invited to work spreading the network, and eventually this is kind of the first chapter. Eventually there will be chapters everywhere where ROG members are. I guess probably a Europe one will be in order soon, and perhaps another parts of USA.
Aldous, did you get that?
It was a invoice there. So, but of course, online is always important, because sometimes it's difficult to just make time to invest in this kind of networking. If you like, guys, I would like to explain the way we thought this meeting. And Juan, maybe you want to help me, but what we did is we were working with Roman, that is, of course, very well deep into autonomy and vehicles, and we want to know all we can learn about the robotic operations regarding autonomy in vehicles, autonomous vehicles. And of course, I don't know if you already have been introduced to Aaron here. Have you? Okay, Aaron here is my good friend, and he's the COO of SUX. So I think we have at least two. I don't know you guys, your profiles, but
why don't we we typically start by going around and having people introduce themselves. So maybe
okay. So
you want to start?
Yeah, of course. After introductions, I want to explain this model. After introductions, we have a set of questions that we prepare with Roman, so that we can ask Roman about these questions, and he can give us some answers. And this will be the way to open the conversation around this question, answering questions. And of course, you are open to modify or interact as you like. So, well, everyone knows Florian here. He's the CEO of In Orbit. You want to go?
Sure. I'm not sure I know everyone, so I just have to reality. I'm Florian. I'm founder of In Orbit. We do robot orchestration. So we're a software company. We don't make robots. We make robots work better together. I'm also the OG founder of the Robot Operations Group with my partner in crime, Joe Wiecek, who is partly Bay Area based now because he goes back and forth. And again, our goal has always been to share best practices with other experts and practitioners always looking to learn from each other. This is just FYI, not the place to pitch a commercial product, but to share notes as candidly as you feel like you can. It's also an opportunity to network and announce jobs, explain that or express your interest in jobs. So we usually save some time at the very end to cover that. Why don't we continue going around the room? Maybe over to you, Andrew.
Sure. My name is Andrew Bennett, and I'm a mechanical engineer working at Microsoft. Unfortunately, right now, I'm not doing anything directly related to robots, although we might do a beta test with a local startup that does like a robotic manufacturing cell, and we might help give them data to help develop their product, but in the same time, their robots might help us assemble some of the tools that we build. So that'll be fun. My role prior to Microsoft, I was actually at a UK-based robotics company called Dextery that did very tall robots that scan the racks in warehouses to keep warehouse management system data, accurate. So a little bit of robotics experience, but not currently. I'm still very interested in robots.
Hi, I'm Gabriele. I'm the founder of IronGrade. I'm an electrical engineer by training, and what we do at IronGrade is that we use the functional safety and system engineering to better understand the risks of robots, and we convert these risks into losses. And our final product is currently an insurance policy. And so the idea is that we blend the engineering understanding of robotics and new hardware and physical AI into basically a risk transfer product, which is insurance.
Richard Pedrazzini here. I'm the CEO and founder of Robotico. We do, as many of you know, robotic operation services and platform optimization services. So we're a service company. And Juan, you want to go?
For sure. Hi, my name is Juan Segundo, and I work in Robotic Crew, and I help basically Ricardo and his assistant. And yeah, nice to meet you guys.
He's putting some work in robotic operation group too. Alan, you want to go?
Sure, I am. So first of all, you overinflated me a little bit. I'm not the COO of Zoox. I'm an executive manager. I'm actually the market manager for, it's ironic, I'm wearing my Dodger hat. I'm the market manager for San Francisco, but I'm a Dodger fan. So I'm in Austin right now, riding around in our test vehicles. I dropped in at Starbucks to take this call for a little bit. But my background I've been with Zoox going on about 2 years. Prior to that, I was the VP of operations for Serve Robotics, helped to bring them public sidewalk delivery robots. So that's me. Thanks for having me.
Thank you. Okay, should we start with
Wait,
Aaron?
there's at least 3 more people.
Oh, I didn't see that. Sorry. I see Roman there.
Hi, I'm Roman. I'm doing mostly robotics part, the fleet management, the ecosystem of the applications, reporting tools, fleet management tools. And I've been working at retail, industrial, and agricultural robotics.
Anyone else?
I can go next. So Aldous von Berg, I'm the founder and CEO of Miley Robots. We are based in Copenhagen, Denmark. We do fleet management for mobile robots as well, with a hardware vendor and industry sector agnostic focus. And yeah, been with Rogue from the 3rd or 4th meeting. And hand it to JG.
What's up, guys? My name is Jose. I'm out here in California. I'm a software engineer. I don't do anything with robotics now. I'm hoping to maybe transition into maybe a career in robotics probably in the next year or so. Just trying to learn.
Is there anyone else? It's the same thing.
There's another person, but it's you, from your
Oh,
family.
that's me.
Yeah.
Yeah. Should we start, Roman? What do you say?
Sure.
So you want to introduce the questions? You want to just start doing it yourself? The way it works better for you.
Anyway, it works for me. So, yeah.
Okay.
We can
Juan,
start
can
with
you
questions.
start with the questions? And please, anyone is welcome to join and join the conversation.
For sure. Give me a sec. Um, So, to start, the first question would be, what is the biggest technical challenge companies face when moving from pilot deployment to fleets operating reliably at scale?
So as I said, most of my experience lies in the area of retail and industrial robotics. I was a part of deployment of the fleet of 37,000 robots and more than 100 agricultural autonomous vehicles. And in any environment, there was no any kind of one single problem. There was a variety of problems, but the biggest thing which I can categorize is like lack of observability tools and processes, because the difference between even pilot and real world support is very dramatic, and it comes quite often. You need to change your playbook on the fly, because every single addition, it's not even every single customer, it's every single location brings some new additions to this playbook. That's why like it's never ending and constantly evolving process.
Does anybody want to add anything or something else, or should I just continue?
Let's move forward.
Okay. So the second question would be, what infrastructure bottlenecks typically appear when fleets grow from a handful of robots to hundreds?
So I'll talk from the cloud side. I think the biggest one for me was the cloud cost. Things like storage, which is related to telemetry, to images, if it's a part of your application. For example, shelf scanning robot was sending the tons of images. The compute cost, which includes things like simulation, model training, and the data traffic, because you got quite large volume of software updates and map updates if your robots are syncing maps.
I can weigh in here.
Sorry.
When it comes to operations of public-facing robotics, the little things that you do in the beginning that help keep the fleet going, whether it's cleaning sensors or cleaning the bots themselves to make them presentable to the public, plugging them in for charging, plugging them in for data ingest. Those little things in the beginning with a small fleet, you just chalk them up to like startup operations, and it's not even a thing. But as you scale, you've got to think systematically about how you're going to process those things, because there's still human touch points. No one's doing L5. There's no Terminators out there plugging themselves in and doing the whole thing. So there's still going to be a human touch point, but you want to try to reduce that and operationalize that so that it's like assembly line sort of process along the way. And that's the last thing that a lot of companies will think about, because they're just trying to grow and get stuff out there. And then they get to a point, they're like, oh crap, we've got too many people doing all these things. So it's really good. It's really important to think about that along the way, scalability. Like, you can accept that we're doing something right now that's not scalable, but you got to figure out how you're going to do it. And that's on the next slide.
Well, since you mentioned sensor cleaning, I think it's a really good addition, because that's something which is pretty straightforward and quite easy for the end customer, but it has really dramatic results on the autonomy, because like wiping out the LiDAR in the dust environment would eliminate a lot of issues like ghost pixels and all this fake alarms. And like that's the part of the operations playbook, which you enhance and give to the customers.
Aren't you raising your hand?
Yeah, I don't think I meant to. This is I don't use Google Meet. Sorry about that, guys. Let me figure that out.
Andrew?
Oh, I was just wondering when Aaron was talking about like the scalability of like small things that are manageable when it's a small fleet and becomes a problem later when you have a much bigger fleet. I was wondering if another example of that would be like plugging in the robot to charge it versus setting it up with a docking station where it can charge itself without the need for human interaction. Is that
For sure? Yeah, for sure. That would be a consideration. I mean, it depends on the application. You know, a lot of the players now in sidewalk delivery are kind of doing depot-less models, meaning they might have a facility that's that can store some of them, but what they're really looking to do is to kind of keep them going, keep them out, partner with some incentive discounts with some restaurants that would be willing to plug them in, that kind of thing. So the infrastructure for that sort of a setup becomes a little bit of a challenge because you know, the key is utilization of these things, right? You want to keep them out there as much as possible. So in theory, that could work in a centralized model, but what I'm just seeing in practice is that a lot of the players are really moving away from having this huge real estate footprint and looking to see how they can just get them out there and have them sort of like be durable and stable and stay out and just do their thing. Go into sleep modes and have some quick in-field servicing to keep them going, and then combining that with some partners as well. But you're onto something.
I think I was reading that Waymo has like kind of gig workers going around because, like, for example, people will exit a Waymo and leave the door wide open. Maybe they think the doors close autonomously, like in Japan,
Yeah,
all the doors open and close autonomously.
So for Zooks, our doors open and close. They open like sliding doors, and they do it automatically because we don't have that problem.
I know you don't have that problem. I'm sure there will be other problems, like, I don't know, like bird poo on your windshield, or like things where like
you know what's
somebody has
surprising?
to do it.
Lost items and spills. There's not a good way. There's no way to automate that sort of a thing. There's automated flows of like where it's going to go and how we're going to get it back to the person, but somebody's got to take it out of there and clean it.
In Vegas, people spills more the drink than in other places.
Yeah, I kind of figured if you're designing your own car, maybe a puke detector sensor is probably mandatory.
Sprinkler system.
I have a question. I don't know if you want to say. So I guess the things that we're talking now are things that once an end user starts using a platform or a vendor, body vendor in the platform, these things are ongoing. So like the door or any other things that happens many times. But there is a human in the loop involved. But there are other things, and these are questions. I think there are other things that happens maybe once, which is when you start a new deployment in a new user, that there are a lot of opportunities to automate or to get people out of the loop. Like, for example, and regarding autonomy, we've seen with one of our customers that the biggest deal is when they work in the wild in the fields. This agri-tech company, and one problem is maps. You know, human maps are not robot maps, so you have to translate that in different ways that I wouldn't know how to do that. But it's a lot of problems to start the job in a new location, because it takes a lot of time to get all the satellite maps and then translate that to something that the robots can use. We're working a lot as humans in the loop to solve that problem, but eventually I think there should be better ways to solve it. That's a question. I mean, that's what I see, but it's also a question. You see also some other.
So for mapping thing, I think it's very important to kind of think about the customer's perception. Like if you promise customers that it would operate from day one, and it operates day one, customers doesn't care that it takes you a week to pre-map the location, right? So like this experience overall should be smooth in the customer's eyes. So it's not like the actual deployment, it's deployment for the customer because it affects their workflow, like how much it interferes their operations, how smoothly you can integrate it into their workflow. That's what matters to them.
That makes sense.
So the third question would be, how do large-scale fleet platforms assign and prioritize tasks across many robots operating simultaneously?
So honestly, in all environments where I was working, all the robots were isolated from each other. Yes, they could split the task, but they didn't communicate to each other and they were not the part of one unified ecosystem. I believe that in the systems where like you got multiple vendors and multiple robots which are doing different operations, depending on the form factor and purpose, right? You do it on the same conceptual base as you do cloud load balancing and message bus, right? Like you got the set of criteria, which could be, I don't know, robot's purpose, capacity, battery charge, the current task robot is doing, the current location of the robot, the SLA, and then the system should allocate the right robot for the right task at this moment.
I think it absolutely does depend on application. For instance, in food delivery or sidewalk delivery, I guess more generally, it's something that I think it can always be optimized, and I'm aware of the way that companies look at it. They look at distance from origination point. They look at distance to delivery point. They look at predictive data of like the follow-on pickup point, and then they try to balance coverage as well, so that it's not as if the fleet is all on one side of town and then suddenly the next orders take longer to get to. So it can get sophisticated over time, and it should, frankly, the more data that companies have, in at least in that sort of application where it's a multiple robots could manage the exact same tasks. I think that that doing that sort of optimization continually is important.
Right.
So the fourth question would be, how do you decide when a task should run locally on the robot, on an edge server, or in the cloud?
That's a really interesting question. So once again, a lot of parameters in this decision, and it should be based on the requirements for latency, data volume, data integrity. If you're doing something which is also has some compliance hurdles, like GDPR in Europe and things like that, you will probably do the face blurring on the robot or full body blurring. If you are doing expensive data stitching, data processing, and this amount of traffic you will send would require like a lot of connectivity, and you got some kind of challenges with integration with customers' Wi-Fi network, so you prefer to rely on your own, or to avoid this extremely high traffic bill on LTE, you will do it on the edge computing. But if your robot is doing something like a floor care, right, scrubbing, and sends mostly like metadata, you can do it in the cloud and do some kind of analytics based on this. So once again, it really depends on the applications and how much of the connectivity challenges you are experiencing.
Sorry, I had a bike. There was a lot of that. So for the fifth question, it will be, how do you deploy over-the-air updates safely across large fleets without risking downtime?
I think the universal rule of thumb is that you never deploy the software updates to the entire fleet simultaneously. You're doing canary updates. The tactics which I usually seen was you do the updates on your test fleet, you run it for a certain period of time, internal test fleet, then you do the software updates on your trusted fleet of early adopters and listen to their feedback. And then when it's ready and it's very well tested and received, you got the updates for the entire fleet. On every single stage, you should be ready to roll back. That's why you need to have robust mechanism like partition swap or something which would allow you to return to the previous state and minimize this downtime.
So the sixth question is, what metrics and dashboards are essential for operating autonomous fleets at scale?
That's really a good topic. We briefly touched it, right? So I would split these metrics in two main categories. The technical metrics, which are mostly valuable for internal development teams, and more like business metrics, which are valuable for management, like robotics company management, as well as customers management, like clients. So the technical ones mostly related to things like interruptions or assists, however you call them, per period of time, like assist per hour, assist per day. Then utilization, like whatever you're doing, manual, teleop versus autonomous time, because that's directly shows how much the robot is doing what it's supposed to do, right? Whether it's supposed to do autonomous work or teleop work. And then think about ROI-related metrics like daily active robots, and things which are specific to the applications which these robots are doing, like area covered, labor hours saved, something which can show the clear picture on the balance sheet and be a driver for the next contract renewal, because you need to win your customers over and over, and this is the key factor customers are doing, judging by your robot performance, not how robot look, not the feedback of the staff, even though it's very valuable, but what your analytics is saying about robot utilization.
So the next one is, how do you convert raw robot data into operational insights that improve fleet performance?
We're talking about analytics on the very large amount of unstructured data or poorly structured data, right? So there is no universal approach, but there are a lot of different applications and a lot of different solutions. For example, if you're talking about the analytical part, right, and you're using data warehouses like Snowflake or BigQuery or ClickHouse, they got their LLM tools which allow you to traverse this data and try to find insights. If you're talking about the sensor data and sensor fusion, like you can use tools like Robota. Once again, it's not like shameless plug. I'm just was researching the topic. You can build your own one, but the idea here is that you got something which is analyzing the sensor fusion threat and looking for anomalies, and you can do it preventively too before the actual problem arises, right? I can search for logs, look for specific combination of factors, or you can build your own heuristics based on known set of rules.
What surprised you most once robots started operating in real-world environments instead of controlled tests?
Everything. Like you think that you're 95, 99% there, but reality is that this 5% gap, right, is something which you cannot really simulate or test, no matter how hard you try, because real world is real world. So things like chihuahuas crossing the path, right, like before the sensor fusion, the black tiles which look like black holes, the escalator detections, transparent walls, all these things, they come by surprise and you need to be ready. So like if it's the first customers you're deploying to, right, even if you went through a robust series of pilots, you cannot really be assured that the robot would work equally well in every single location, because there are no similar customers and there are no similar locations. Every single one is unique. You can cover 90-something% of similar cases, but there would be always variety of cases. So you need to be just prepared and take it as granted.
So the next question is, what infrastructure issues most commonly appear when deploying fleets in new environments?
Once again, if we're talking about infrastructure, cloud infrastructure, right? From my perspective, the majority of the issues are on the connectivity side, where you got challenges integrating with the facility network, spotty signal, the speed, the latency, the lag if you got worldwide fleet, right? Like, and you are not having replication of your data centers all around the world. The next one is acceptance by the personnel and management. If the company's management is very excited about robots, it doesn't mean that their workers, the end customers, the end users, which you can treat as end customers for your robotic product, are happy about that. So you need to find a good traction with them, because these are the people who would prepare the robot. They would wide the sensors, they would recharge the robots before work. And it also directly impacts the integration process into their operating workflow, when they would need to modify their, let's say, restocking schedule to make sure that the cleaning robot is not blocked by restocking team, because they need to spread their schedule on time and make sure that it's not blocking. In many other situations, they need to modify and make sure that this robotic solution is smoothly integrated. And the last challenge is that for many of them, for many of the customers, it's really nice to have, or sometimes very mandatory thing, to have integration of your robotic system output into their internal tools, whether it's like farm management software, warehouse management software, because nobody wants to have multiple applications, right? So it's a big topic by itself, right? Because you got multiple ways to do this operation. You can have webhooks, you can have API integrations. But overall, I've been in multiple situations when customers, my customers, which are customer employees, were carrying, for example, like in big box stores, 6 different mobile devices for printing price tags, for planogram compliance, for deals, and for robotic inside actioning. So like instead of running 6 different applications on one device, they were carrying 6 different devices and they were handling in the cart. That's very suboptimal case, and ideal solution should have more smooth integration end to end.
So the next one is, what does the ideal remote operation stack look like for managing fleets across multiple sites?
I think you need to have two main layers. Like the first one is fleet view, the bird's eye view, where you can see your whole fleet overall, like fleet health, like what kind of regressions did the last software update cause, if there are any, the sites, the routes, things like that. And you need to have the robot in-depth view where you can see the details about the particular robot. It's more like tech services level, where you can see the operations metadata, the telemetry data, like all the kind of information in the scope of the particular robot and potential problems which can come with this robot, including things which can help you with like preventive maintenance or the current state, like robot health.
How do you integrate robot fleets with existing infrastructure, such as doors or safety systems?
This is something which you do case by case basis. There are a lot of IoT devices and infrastructures. So for your particular case, I think OpenRMF is really good foundation. Unfortunately, not many systems are adopting that. But in my use cases, I used to work with multiple situations when like autonomous sprinklers on the field were acting on their own schedule. Yes, they had API, but we had to build the custom webhooks to connect to the systems, and they were not always reliable. Like you cannot really assume that all parts of your systems outside of your control would be reliable and sending the accurate data.
Does anyone have any comment on what we have been going through so far? Maybe Aldous.
I think Roman has been nailing the points pretty accurately.
Well, definitely, yeah. Go ahead.
Yeah.
I think things like VDA 5050 and all the other standards would be something which we should come up sooner or later, because without standardization, it would be always the zoo of different integrations with various degree of reliability.
I could probably make a comment on the VDA. Now that they have published version 3, they clearly better defined. So with the comment where you the setup, getting the robots out there, a lot of the times on the previous versions of VDA has been left to the interpretation of the text to follow, while Florian, you're shaking your head as well, or nodding. I think you've also been there where one party says, oh, we interpreted this, and then we interpret it the other way.
And in practice, people had to make custom connectors for each fleet manager, even though the basics were the same. So it's not turn it on and it works. No, but I would say those are, to be a little generous, I think those are growing pains for standards, and it's always a difficult balance to figure out what you want to specify versus what you want the market to figure out. With a very mature standard, like I don't know, like USB-C, then you can be very explicit. But if you're too narrow, what happens, my experience with standards, is the people in the room have an idea of how the world should be, and then the world has its own ideas, and they don't line up. So if you're too specific, you're screwed. If you're not specific enough, you're screwed. So it's a really tricky balancing act. So I do agree that it seems that the VDA 3 is a good step.
Yeah, it's much better defined and more clear. But yeah, with the interpretation across the world, we've seen that firsthand with the ISO standard. That has been, yeah.
I think it's nice to have this list of questions, but I don't want to leave the conversation without anyone being able to ask the question that probably you came here to find an answer. Does that make sense, Florian? Like, if we could use the rest of the call to make sure that everyone just that is present today has a takeaway that he desires. So, if anyone wants to share what
I'm actually interested. For example, Gabriela, you work you founded Iron Grid, and you're ultimately building insurance. So,
Yeah.
what are the signals that Yeah, because I think for humans it's like smoking, non-smoking, those kind of things, age. But with robots, what are you looking for?
So what we try to do is to use functional safety as a proxy for the failures that we expect in the system. We start from industrial robotics. So you mentioned the standards. Standards are hard to meet, but we start from industrial robotics where companies are a little bit more, along the way, right? And the point is, insurers have no understanding of any new hardware, even industrial robotics. And so what we're doing is there a way to quantify the risk of a robot? And functional safety, the good thing is that you can specify each function with a probability of failure, and you can relate that into a probability of having a loss during operation of the system. It could be a loss. We have two ways of thinking about that. One is, you are the OEM of the robot, and then you sell the robot, and it's what's called in insurance product completed operation. So it's operating, you sell it and then something happens. And that something happens is, you can use qualitative understanding, and based on that, just, price the insurance. Our goal is, can we use engineering understanding and price that, the policy? In the end, insurance for us is a risk transfer, and our goal is, can we help also startups to just deploy faster, or like if there is a new hardware coming, can we basically be the one that understands better the hardware and help those companies to just deploy the first product? So everything started there.
But I have a question. Like, if I'm, again, we work primarily with mobile robots. I don't know if that's okay. So if, let's say I'm deploying like an autonomous forklift, and there's like many hundreds of companies making those. But I deploy it at this particular factory. Who's taking out the policy? Is it the end user or the OEM? And what other external information do you need about the application? Because if you look at our 1508 and some of these things, it's not just the robot; it's the robot and the environment.
Yeah. So when it comes to those applications, so for example, depends on the type of policy in general. So what we do is what's called CGL, so general liability. So this means that the policy is bought by the OEM or the system integrator, and there is a portion of the policy that covers the product completed operation. So basically, when you sell it, of course, it's a liability. So there are a lot of legal, boundaries. So for this type of policies, the good thing is that what we need to understand is what's the probability of something happening on the field. We don't need the additional data from the end user to better understand what's happening. However, if you move to a workers' compensation type of policy, in that case, which is something we're thinking about, in that case, you will need access to, for example, cameras, or how is the robot operating or the fleet operating in the warehouse, and what's the interaction with the humans. In that case, you would need data, because that basically would be, you could also think about direct payouts if something happens. Like, you don't need to have like a claim type of processing, or you can basically just basically understand should it pay out or not. For this first product, though, we are avoiding having access to too much data, because we need, first of all, to prove the concept, and prove the concept with the general liability is basically I would say the best compromise between complexity and convincing the reinsurer. After that, the next step is definitely to have access to data and then move right to the end user point of view, which is workers' comp, generally speaking, or performance guarantee too. Like if you're down, it could be also downtime type of like plays. Like you, for example, you have the fleet should perform in a certain way. If it doesn't, you pay out. So when you go to the end user, there are different plays you can do.
Isn't that typically like in an SLA or something like that? Is that really an insurance question?
It becomes what they call parametric insurance. So it's like saying, for example, your robot should perform in a certain way. If it does not, I pay out. It's very common with downtime for warehouses. So let's say, or even batteries now. For example, batteries should perform at a certain power level. And if it does not, you pay out. And there are solutions coming out in that, in that context. It's very hard.
So who pays out, the OEM or the insurer?
Insurance.
Oh, interesting.
This is basically, it's like
So
saying,
you're transferring the SLA risk to the insurer.
ourselves,
Yeah.
let's say that when you move to those places, you need a lot of capital. So because it could be, you need a lot of understanding of, does it make any sense to cover the risk? And so this is why we started from a CGL, because it's from the OEM point of view, and generally losses are high, but they're much lower than what you would expect from the end user. And this way we can, we need to convince the reinsurer partner, which is UK people like Lloyd's, those guys. And so it's a compromise between innovation on the way we answer risk without asking for too much data to the OEM, without making the process too cumbersome, basically.
And would any of the data that Roman was talking about help you with assessment?
One question that when you mentioned that, about I think it was one of the first questions, I forgot now, but the technical specification, and you mentioned that some come from compliance and some from the end user or from the needs basically of the end user. And I'm wondering what's the percentage. So how much is coming from just meeting compliance and how much is coming just from the specific end user needs basically? And I think it was the fourth question. I forgot. Yeah, fourth question.
You're asking Roman, right?
Yeah.
Okay.
Sorry, I didn't pay attention. Can you repeat your question, please?
When the task runs locally, no.
Earlier you mentioned about some basically the specification that some are coming from, compliance needs, and some are coming from the end user needs. So, where you need to deploy the robot. And I'm wondering what's the percentage? So how much is compliance guiding your design choices when you're
a lot. It was a lot of pressure. I was working on the application for shelf scanning robots. A robot has 6 cameras, and it basically captures the whole store. And there was an add-on on the top which had 360 cameras. So for that kind of use cases, you got basically tons of images and the compliance requirements to run it in the European market.
Wow.
But it was pretty strict. So face blurring and the data was governed. So in our cases, the data was blurred on robot for one generation of robots. It was able to do blurring on the other one, but the condition was that the people should not have access to this data. So unblurred data is accessible only to service scripts, service permission users, and all the internal users would be accessing this data only after it was pre-processed and phase blurred. And it's one of the many other requirements, but that's the most noticeable one.
Do you think it's much harder in EU compared to US?
Definitely.
Because it is, but how much? How much does it change for you? Yeah.
But you don't customize the solution. Like we do this thing in Europe, we do this thing in US. You build one solution for all the markets, so you make it the most strict. And let's not forget that there are some customers in US which may have their super strict compliance, which are even harder than European ones. Like the one with the red circle, I won't name it, had something which was the most strict thing I've ever seen in my life. I was working at hedge funds. I was going through authorization with like finger and retina scan, but that was nothing comparing to the compliance requirements they gave us. Yeah.
Hey, we have just a few more minutes. Let's go through other business. So thanks, Roman, and thanks for the questions, everyone, and the contributions. Just a couple of quick things. One is, who here knows that we have a Slack, a shared Slack that we can participate in? I see Roman, Andrew. So anyone who wants to stay connected, Ricky, maybe you can share the mechanics. So that's one. Anyone hiring that wants to promote what they're doing to the world?
I'm not hiring, but one of our consultants that we had for the backend is now available. He's located in Copenhagen, but can work remotely. So even backend DevOps kind of positions. So if anyone is looking for someone located in Europe who has that skill set, I know.
Okay, I'm looking. There's a few roles, but probably the one that I would promote now is a customer success manager who primarily will work remotely, but occasionally have to go on site to make sure that things go well. I would say based anywhere in the US, as long as they're not far from an airport. So if you know anyone and want to refer them to me, I would be most appreciative. Anyone looking for a job here who feels comfortable saying it? It reminds me of that episode in Silicon Valley where all the engineers try to get hired by one of the founders, but the founder says, "Hey, are you guys hiring? My startup is going down next week." So somehow that's always in my mind. Any other announcements from anyone here? All righty. Okay. Well, I think with less than a minute to go, I think we're wrapping up our first Bay Area chapter, even though half of us were in the Bay Area. If you have any ideas for how we can make this better, then join the Slack channel and then share there, and we'll, this is our community, so it's up to all of us to make it better.
Yeah.
Awesome. Thanks, everyone.
Thank you, guys. Bye. Thanks, guys.